Hello and welcome back to my Blind 75 series. Today we're going to be talking about merge two sorted lists. This is an easy level question. Let's go ahead and read through this problem. So you are given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists and then return the head of the merged linked list. All we're going to be doing is we're going to be taking two lists essentially and just putting them together so that they're in order. And then we're just going to return that list. And if we look down here in the examples, what we're going to see is that if both of the lists are empty, we're just going to return the empty list. And then if the list happens to have, one of the lists has values inside of it, then we're just going to return that. So in the situation that it's empty, return empty. In the situation that there's values, return a value. And we're going to be solving this using two different examples. The first example is going to be a recursive example. And both of these examples are going to have a time complexity of O n plus m. And the recursive example is going to have a space complexity of O n plus m. The second example that we're going to be looking through is where we're just essentially going to have a pointer at the start of both lists, and then we're going to traverse both lists and compare the values. Before we hop over to the example, please take this time now to like and subscribe to this video. Really helps me out. That all being said, let's get started. So both examples are going to be pretty similar in how they're going to be solved. But pretty much all we're going to be doing is we're going to be looking at both values here. And we're just going to be comparing them. So we have these two lists. We have list 1 and we got list 2. And all we're essentially going to be doing is we're going to have a pointer at each one. And you're going to be having the value here. So we'll have this current. So current 1. And then we'll have right here current 2. And what we're going to be looking at is we're just going to see if the value is greater or equal to. Greater, equal to, or less than. So in the situation that we have here, we have 1 and 1. So we have a C1 and a C2 are both equal to each other. Now you can either have it so that the list 2 is going to be the value that's going to get taken over, or you can have it be that list 1 is. So in this situation, I'm just going to have it where we're going to take the list 1 value first, and then we'll put the list 2 value second. So we're going to have list 1 here and list 2 here, and both values are going to be 1, and then we're going to link those together. So after that, we just move our pointers over again, and we're going to compare once more. We're going to check if 3 is greater than or less than to 2, or if 2 is greater than or less than a 3. And in this situation, our L2, 3, is going to be larger. What we're going to do here is we're going to see that our 2 is going to be the next value, so we're going to add that on to our new list. We're going to create our link here, and we're going to move that 2 over. So we have the 2 here. We're going to move this one, but we're not going to move this value yet because we have not added it on. Now we're going to once again compare. So we're going to compare 4 and 3. Now, is 4 greater than or less than 3? Well, we know 3 is less than 4, so we're going to add that value on right here. So we're going to put the 3 on and add that in. So now we have these values are gone so far, and we're going to move this one over. We kind of have the same thing as we had before. Both these values are equal. 4 is equal to 4, and like we did before, we're going to take this value first. And you can do it either way. You can choose to take from the L2 list first or the L1 list first. It's really up to you. What we're going to do is take that L1 value first and add it to our list. So we're going to add in the 4, cross that off, and then we're going to add in the other 4 right here. And we can cross that off. And now we have our new list. At the end of this, we're just going to return the head value, which is actually going to end up being head.next is the value that you return. But this is essentially how the basic logic is to solve the problem. So let's go ahead and code up the recursive version, and then we're going to go ahead and go over the iterative version as well. All right. So first we're going to go over the recursive solution, and the recursive solution is going to start off with our edge cases, also our base cases, and our base case is going to look like this. So we're going to have if L1 is none, then we're going to return L2. And then similarly, we're going to write L if L2 is none, then we're going to return L1. So the reason for this is that in the situation that you have a recursive, so in any recursive solution that you have, you need to think about what your base case is. So in the situation that the below information that we're going to add no longer works, no longer is the situation, like the actual recursion, we need to have a way to stop the function from continually running forever. So in the situation that we want it to stop running forever, it needs to either be that we run out of nodes on list 1 or we run out of nodes on list 2. So in the situation that we run out of nodes on list 1, we're just going to return list 2. And same thing, vice versa. So we're going to just be merging the two lists and into one list, and then we're going to return the list that is still technically available. And that just means that we're done because there's no nodes on the other ones, so we're just going to return L1. And from wherever that value starts at, that's how you are going to return it, and that will return the entirety of the new list that we have created and merged together. So for our next step, we're going to create another elif statement, but this one is going to be looking at the values of L1 and L2. And let me actually fix this right here and make this L1, L2 to make it a little bit shortened. So the original one, we're going to be just less than L2.val. The next one's going to be a comparison between greater than or equal to. But for the first one, it's just going to be L1.val less than L2.val. And then we're going to do L1.next equals recall the original function, so self.merge two lists, and then call it with the next value in L1 with L2 because we still haven't moved forward in L2. So our L1.next is going to be used in the recursive function. It's going to be once again going all the way back over and seeing if L1 is none, then we're going to return L2 because that means we're done. We've gone through everything, we've merged them together completely. So in the situation that we have here, we take these two values, is L1 less than L2? Well, no, so this doesn't work right now. So let's kind of keep going back through it, and then we'll look at it again. We're going to return L1. So this isn't the case that we're going to be looking at right now. This isn't the ends up being the case that works for this situation. So instead, we're going to make our last case, which is L2.next equals self.merge two lists L1.L1 L2.next, and then return L2. So this is the situation that we're going to be getting right here in this case that we have, is we have 1 and 1. So they are equal to each other. So it's not a less than, it is an actual L1.val is greater than or equal to L2.val. So in that situation, we're going to move over to L2.next, and L2 is going to be our first value here. So as you can see, it moves right here, and we've decided that L2 is the first one in our value. And you can do it with either node. So you can decide that you want to have L1 as the greater than or equal to, or L2. It's completely vice versa, and you can do it either way that you like. But in this situation, we have decided that L2 is the value that we're looking for if it is less than or equal to. So that's the first value. So we've gone out here, we're done with this value, we're now here. That's why L2.next is going to equal this next value here. So we call it return L2, and then it restarts again. So now we are at 1 and 3. Same thing, is one's bigger, 1 or 3? Well, 1 is smaller than 3, 3 is larger, so 1 is going to go next. And then that's when this situation is going to be called. We're going to do the same thing then. We're going to make L1.next equal to the recursive function, L1.next L2. So we're going to be using that value as our next value to call the list. So this list is now only these two values, and this one is these two values, so we no longer have this list here. We just have these two values. And then we keep moving along doing the same thing until we create a brand new list right here. And this is essentially all the recursive function is doing. Now, what's kind of the downside of this recursive function is like the iterative function that we're going to be looking at as well, or the iterative example. It's going to have a time complexity of O n plus m. So if we go here, we set our time complexity, the time is going to equal O of n plus m. And the reason for that is because the time is determined by how many nodes are in list 1 and list 2. So that's how much time it's going to take. So if there's, x values in the first list and y values in the second list, then it's going to take, no matter what, as much time as it takes to get through both. So if you had one list, it'd be O of n to traverse that list. But in this situation, we have two lists, so it's going to have to be the size of both. The space is also going to be O of n plus m. And the reason being is because, once again, the space is determined by the size of both lists. So we are going to be determining the size of this new list by how long these both are. So the new list that we're creating is going to be the same as either one. That is the recursive example. Let's go over the iterative example. So next we're going to look at our iterative solution. And for the iterative solution, we're going to first create a new list, and that list is going to have an empty value that our head and tail are going to point to. So we're going to do head equals cur, which is going to be the current node, equals to list node 0. And this is going to be our new list. And this is going to be the list that we're going to be merging our values onto. How this is going to work is that our head and our tail currently point to the first node in that list, which is 0. And that value is actually going to stay null, and we're going to just be adding on to that value. So we're going to always be tail.next is going to be the value added on, which is going to be cur.next. So cur is going to be our tail value. What we're going to do first is, much like we did with the recursive solution, we're going to have L1 and L2. While L1 and L2, so while we have values in our list, we're going to check if L1.val is less than L2.val. So in the situation that L1.val is less than L2.val, where current.next value, which is our tail, is going to equal L1. And then after that, all we're going to do is increment the value in L1. So L1 is now going to equal L1.next because our L1 value has just been added on to our new list. After that, we're going to handle the other condition side. So in the situation that L1.val is greater than or equal to L2.val. So in that situation, our current.next is going to equal L2. And just keep in mind at the same time that these values can be switched. You can do the exact opposite of this and do it completely, swap all the values, but it's going to be the same backwards and forwards. In the situation that L2 is less than L1, or if it's equal to it, then we're going to add L2 to the list instead of L1. And we're going to increment our L2 value. Then at the end of that, we're going to take our current value, so current, which will be whatever is the new value that we added either from the L1 list or the L2 list, and we're going to take current, and we're going to move it to current.next. So this is, once again, as I said, current is our tail, so current.next is going to be our tail value, and this is going to, currently this is null, but this is going to become either L1 or L2. And this is outside of our loop. Current.next equals L1 or L2. And this line right here handles the situation in which this line, while L1 and L2, no longer is true. So if there's no more L1 values, so say the list 1 and list 2 are not equal to each other and we have more in list 1 than we didn't have in list 2, then our current.next is going to be our last value, which is either going to be L1 or L2 or just the rest of L2 or L1. This is what makes this problem a space complexity of O of 1 and what makes this problem more efficient than our recursive solution. So the space is not determined by how many nodes are in the list. It's really only determined by how many nodes are between the two that we need to add, but that's going to be constant no matter what. And at the end of this, all we're going to do is we're going to just return head.next. And if we run the code, make sure it passes, submit it, we get 85.20. And then if we compare that to the recursive solution, we submit that, we're going to get about the same because the problems are the exact same size. But in the situation that we had a list 2 or list 1 that was in larger size than the other one. So in this situation, it's going to be because the lists were both equal, so it's going to have the same kind of space. But in the situation that it was where list 1 was really big and list 2 was small, then this space complexity right here would be different. But this is both solutions for this problem. There is other ways to solve it, but I felt like these were probably the easiest ways to solve the problem that you will be able to talk about and explain in an actual interview setting. If you enjoyed this tutorial, please let me know in the comments, and make sure to subscribe to my channel for more Blind 75 videos and other videos related to software engineering. Also make sure to like the video for the YouTube algorithm. But until next time, hope you have a good time coding and take care.